Alrighty, graphing exponential functions. Look at the parent function. Okay, they will always have a horizontal asymptote, and then we have what is called exponential growth. Okay, as x increases, so does y, and then we have exponential decay. So you have something, and then it's going to eventually get to close to zero. Okay. So those are the parent functions of exponential growth and decay. Now, if you just look at that, you can tell that the domain of these types of functions is x is the element of all the reals. Now, in these cases, for our range, we have those horizontal asymptotes, which is that line that we will never cross, meaning if it's above it, we're going to have something that is y is greater than, in this case, 0. Again, asymptote is a line that a graph approaches but never crosses. So exponential functions involves the expression b to the x, where b is positive, and that is our base value. And it's also not 1, because if we have a base of 1, 1 to any power is just always 1. So that changes nothing if we had a base of 1. Okay, so in general, basic exponential function is in the form of y equals a b to the x minus h plus k. Again, we got that a, h, and k value, just like we have seen all year. Okay, and we always have that horizontal asymptote. Again, h and k are those shift left and right, up and down, which will, in this case, give us what we're going to call a new origin. Okay, so functions of the form f of x equals a b to the x, where a is greater than 0 and b is greater than 1. So in this biggest thing here, that base value, whatever we're taking to a power, the x power in this case, if that is greater than 1, that is going to be an exponential growth function. Now, if that base value is between 0 and 1, so like 0.5, 0.75, 1/2, 2/3, whatever, anything between 0 and 1, that is going to be an exponential decay function. So again, if we had y is equal to, let's just say 3, and we got a base value to the x. If I want to make it a growth function, this base value needs to be greater than 1, so I'm just going to say 2. You could say 1.01. That's still greater than 1. As long as it's greater than 1, you're good. If we want to decay, we just need to make sure we're between 0 and 1. So I typically just say 1/2. Okay, exponential growth and decay. H and k again we see in this chapter. H is that horizontal shift, k is that vertical shift. So if we look at this function here, y is equal to 3 times 2 to the x minus 1 minus 4. This with the x minus 1, that's saying I'm going to have a shift right 1 unit and a shift down 4 units with that minus 4. Okay. So then again, a, that's kind of that stretching that we do. And then in exponential functions, that horizontal asymptote is always going to come from that k value. So just looking at one, you got 1/2 to the x. We don't have an h, because I could say x minus 0 plus 0. We just got a origin of the original origin. Again, we have a horizontal asymptote. And when we do these, we're going to do an xy table. Oh, I'm sorry, we're not doing an xy table. We're going to use that parent function just like we have. We got x, and the x values we're going to use, -1, 0, 1. We're going to take our base value to the x, which is 1/2 in this case. So this is saying 1/2 to the -1st, 1/2 to the 0, 1/2 to the 1st. Anytime we take something to the -1 power, that's saying just take the reciprocal, so 2. Anything to the 0 power is 1. Something to the first power is itself. And then again, if we were to have an a value, which would be right here, which is just 1 in this case, you'd take that column, multiply it by that a value. In this case, it's not going to change at all. But say it was 2, you're going to take that middle column times 2, and that'll give you your third column values. If you remember, we ignore that middle column once we multiply by that a value, and that's saying negative 1, 2, that's saying left 1, up 2. And we're always going to go from our new origin. So just up 1 in the next one, and then right 1, up half. And again, as we approach an asymptote, closer and closer we get to it. Again, domain is always x is an element of all the reals. Range in this case, it's above the asymptote, so greater than, and it's above that value of 0. In the equation, horizontal line is a y equals, and it is y equals 0. Okay, this is an exponential decay function again. If you look at the base of 1/2, that's between 0 and 1. Okay, moving on. Look at our h and k. hk in this case is going to be negative 1, negative 2. Again, it's always opposite of what you're seeing with that x. It's always x minus h, so you got to think opposite. And this is supposed to be plus k, so it's plus negative 2. So negative 1, negative 2. Okay, so we're going to mark that new origin. And again, we have a horizontal asymptote with exponential functions. Okay, exponential, again, we have a variable as an exponent. So, do our little table. Negative 1, 0, 1 for x. We got a base of 1/2 to the x, but now we got an a value of 3. Okay, we knew that 1/2 to the negative first was 2. 1, 1/2. Again, now we need to multiply by 3. So 6, 3, 3/2. Ignore that middle column. Negative 1, 6 is saying left 1, up 6 from our new origin. Okay, just up 3. And then we're going to go right 1, up 3/2, which is about 1.5. Okay, 3 points minimum. You can always do more values if you wanted to. As we approach an asymptote, the closer and closer we should be getting also. So again, if you want to do more values, I can do 2. If you do 2 to the 1/2 squared, that's 1/4. And then 1/4 times 3, that's 3/4. It's just going to get closer and closer to that 0. Domain, x element of all the reals, just like all the other ones. We're going to be going left and right with this graph forever. Range, we're above our asymptote, so again, it's greater. And that asymptote is at negative 2. So, and the equation of our asymptote, again, is y equals negative 2. Okay, if you notice that k value is going to give you that range and the equation of the asymptote on exponential functions. Look, moving on. Okay, now we're going to have an exponential growth since our base is greater than 1. We got a base value of 3. Looking for our h and k value. In this case, 2, 1. 2, 1. We have a horizontal asymptote. Okay. So then x, minimum, negative 1, 0, 1 I want to see. We got 3 to the x this time. So 3 to the negative first, which is 1/3. 3 to the 0, which is 1, because anything to the 0 power is 1. 3 to the first is 3. So then now we need to multiply by 2. 2 times 3 to the x, so taking that middle column times 2. So 2/3, 2, 6. Ignore that. That's saying left 1, up 2/3, up 2, and then right 1, up 6. Okay, that's good enough. Coordinate plane there, that's okay. And again, as we go along an asymptote, the closer and closer we should be getting. Okay, domain is not changed on any of these because the domain of all exponential functions is x's element of all the reals. Range, in this case, y, again, we're above it again, so y is greater. And we're going through 1, so y is greater than 1. And then my equation of the asymptote is y equals 1. Okay, just changing it up a little bit. We're going to have a negative a value here. HK. We got negative 2, 3. So negative 2, 3. Got a horizontal asymptote. Okay, so doing our table, x. Negative 1, 0, 1 for x. Now we got 2 to the x. Now we got an a value, so negative 3 times that 2 to the x. 2 to the negative first, that's 1/2. 2 to the 0 is 1. 2 to the first is 2. Now we need to multiply that column by negative 3, so negative 3 halves, negative 3, negative 6. So left one, down 3 halves since they're both negative, just down 3 from the new origin, and then right one, down 6. So just connecting our points, making sure we're going along the asymptote and getting closer and closer. Domain the same. Range, in this case, since now we're below the asymptote, it's going to be y is less than, and that less than value is 3, meaning the equation of our asymptote is also y equals 3. That is all we got. That is graphing